In this video, we will talk about common operations on sets. So one of the most common operations on set is what we call union. It is represented by a symbol which is like a U, which says A union B. And what it means is it is an X which belongs to A or belongs to B. Right? So how do you understand this? X says that X belongs to A or X belongs to B. So let's take an example to understand it better. So let's say there is a set A, just 3 elements. And then there is a set B, which has 4 elements. So what does an A union B means? So let's get back to our Venn diagram, right? So we'll say there is a universal set U, which is made of 1, 2, 3, 4, 5. Right? There is set A, and there is set B. So X belongs to A, which means all this value, and X belongs to B, which means all these values, right? So X belongs to A or X belongs to B, which means X belongs to A, so it will take a value 1, 2, and 3. And then it says X belongs to B, so it will take a value 2, 3, 4, and 5. However, we know that sets is unique, so we don't repeat the value 2 and 3. So we just add the value 4 and 5. We call this as A union B, right? So all of these elements either belongs to A or belongs to B. And this is called A union B. As the name suggests, it's a union of two entities, A and B. Now let's define another operation, which is called intersection. It is represented by an inverted U. So you say union was represented as this, then the intersection is represented as inverted U. And if you see what does that mean, it says it belongs to A and belongs to B, right? It should belongs to both. So now let's take the same example, right? Where A is 1, 2, 3 and B is 2, 3, 4, 5. Now it says X belongs to A, right? So basically all of this element. And X belongs to B. The only area which belongs both to A and B is this, right? So if I need to write A intersection B, I would write that set as 2, 3. So these are the only two values which belongs both to A as well as B. Right? So the intersection, you say A intersection B is the values or the objects which are common to both A and B. Right? Okay, let's talk about the third operation, which is difference. Difference of two sets is basically you have set A and you subtract all the elements of B from it. So it belongs to A but does not belongs to B. So if you look at the same example, all the elements which belongs to A is 1, 2, 3, and all the element which does not belong to B is this. Right? So if I say A minus B is basically 1. Similarly, if I have to say B minus A, what does that mean? If I go by the definition, it's an X such that X belongs to B and X does not belongs to A. Right? So it belongs to B, so this is the value, but does not belongs to A. So this is this value. These are the value which belongs to B, so this will nothing but so B minus A would be defined as I said 4 and 5. Right? This is called difference of two sets. Note that A minus B is not equals to B minus A. What is the circumstances where A minus B equals to B minus A is only when A is equals to B. Otherwise, A minus B is not equals to B minus A. That's clear from the definition. This here X belongs to A, here X belongs to B and not belong. Here X belongs to A and not B, here X belongs to B and not A. So hence A minus B is not equals to B minus A. Great. Okay, let's talk about another operation which is complement of set A. So what does that mean? It is represented by A prime. It says complement of set A is all X which does not belongs to A but belongs to a universal set. So basically it's a difference of U minus A. So we already talked about difference before. U minus A. So say there's a universal set U which has values 1, 2, 3, 4, 5, 6, 7 up to 10. And then there is a set A which has values 1, 2, and 3. So we'll say there is a universal set U which has value 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then there is a set A which is basically value 1, 2, 3. So union is anything but A. Sorry, complement of a set is anything which does not belongs to A but belongs to U. So in this case, it would be these values. Right? Anything which does not belongs to A but belongs to U. So therefore, A complement is equals to 4, 5, 6, 7, 8, 9, and 10. Which is nothing. Q minus A. Good. Now we have seen so many operations with set. We will conclude this lecture by giving you a certain quiz which you need to solve. In the subsequent video, we will provide the solutions for those quiz questions. Now, given now we have understood what is union, what is intersection, what is complement, what is the difference of set, there are various properties which sets follows. Example, De Morgan laws, distributive laws, cumulative laws, and associative laws, and so on and so forth. We will take these one by one, but let's do it as a quiz, right? Can you use Venn diagrams to prove these properties of sets? See you in the next video where we will be talking about all of these properties. Thanks.